Sometimes we're given data and we need to find the equation of a line or an equation of a curve that can go through this. Specifically, we're going to be looking at quadratic models / regression. Now, before we even get to that point, we have some background information we need to talk about first. When we're looking at this, we're going to specifically be talking about a correlation coefficient. Sorry, I should write that a little bit bigger. Now, a correlation coefficient. This is an R value in which it's going to tell you how likely the data will fit a curve So, for instance, if I were to have R equals 0.965, this really represents that 96.5% of the data will fall on my regression curve or line. Okay, so looking at that, that's a pretty good percentage. So we would say that this is a strong correlation. Okay, now a strong correlation is going to be represented in terms of 50% or higher. So let's say R is greater than 50%. We'll make that equal to. Obviously, you could have 100%, but you can't have over 100%. For a week, this is going to be less than 50%. We also have the option of positive versus negative. All this represents is whether the R value is positive or the R value is negative. This is also determining the direction of your data. Is your data going towards the negative direction, as in like a negative slope, or does it have more of a positive slope? Looking at that kind of information. So background information on that. The other background information, we have two different types of lines that we've talked about so far. So far, we have talked about a linear, which is in the form of y equals mx plus b. And we've also talked about quadratics. In standard form is y equals ax squared plus bx plus c. So this information is going to come in handy when we get to Desmos and we need to type some information in. So looking at this first one, I have some data here of a pumpkin, and using a catapult here, the pumpkin is being pulled back at 20 degrees, and when I release that catapult, it traveled 372 feet. And you can see all the data represented. So if I think about this, this is going to be best represented. So if this is my little pumpkin here on a catapult, and I'm chunking it, it's going to have that arch like a quadratic. So this is going to be a quadratic model. Makes sense, right? Because you're shooting it, and then it's going to, at some point, it's going to have a peak and then drop back down to the ground. Okay? So in Desmos, we can actually use this data in order to find the line of best fit based on our data points. In order to do that, we're going to go to Desmos. There's a plus sign up at the very top here in which you're going to click, and then, okay, not working for me. Hold on. If you click on this, this will show up and give you some options. Notice I've got some options. We're going to list a table. It's going to automatically pull it up as x1 and y1. So thinking about my data set here, my angle determines how many feet that pumpkin is going to fly. So my angle is going to be my x. So I'm going to enter in that data into my x and y coordinates respectively. So if I were you, I would maybe, write down what are the steps that I did or am doing in order to type this into Desmos. Okay. So I have my data here. We already decided that this was going to be more of a quadratic form. So since this is in terms of x1, y1, we're going to go y1 tilde. The tilde button is shift and then the button to the left of the 1. Okay, that's just telling me that I'm having an approximation for my equation, that I'm doing a regression here. So we know that our quadratic is in the form of ax squared. So I'm going to type in a, but my x is in terms of x1. So I'm going to have x to the first there. Notice it popped it down. Then I have to do my shift 6 to get my caret if I'm on the right line. Okay, so as you can see there, I've got the curve, but I need to keep going. So plus b x1 plus c. Now I actually have more of a parabola. These data points, if I zoom out here, these data points are shown. So my data points are shown, and this is the regression curve or the model that best fits those data points. So looking at it from this perspective, that actually fits pretty darn well. In fact, my equation or my regression model is now going to be y equals negative 0.261 x squared plus 22.591. Ooh, just gonna, you keep going with me here. I'm just gonna make it shift it over here. Plus 23.029. This right here is my regression curve. So if I'm looking at this and I were to say, okay, after, if I put the angle at 45 degrees, you should be able to plug in that 45 into those x spots in order to figure out how many feet that pumpkin is going to travel. Okay, so the other thing to note here is our correlation. How strong or weak is our curve? Looking at this, you guys can see that it's pretty strong because the curve goes through quite a few of those data points. With quadratics, we have r squared. So in order to get the r value, you're going to obviously have to take the square root of this. Now, the reason why it's squared is because with this, we don't necessarily have a direction in terms of strong or weak. So that's why we just list the r squared. So you actually have to calculate the r then. So I take the square root of that. And my r value is going to be 0.99649. So that's pretty darn strong because it's at 99.65% of my data will fall on that regression curve. So you can look at all of our data here. You can look at the regression curve. If it were a linear model, it'd be similar. You would type in your y1 as approximate to mx x1 plus b, and it would show up the same type of thing. So the main thing is make sure you're entering your information in correctly. So again, if I were you, if you need to, go back through and write down the steps on how I typed that in. Okay, how did I get the tilde? you know, that kind of information. Okay, so this is going to give us our regression model.